Hey everyone! Today we're going to tackle a really nasty back-end performance problem, one that can take down your whole system. It's called the Cache Stampede. So let's jump right in and figure out how to tame this thing. Okay, I want you to hold a number in your head, 1,000. Now, this isn't just any number. Imagine it's 1,000 users all hitting your app, all wanting the exact same thing at the exact same time. So what happens? This is the question that should keep developers up at night. You've got this massive wave of traffic, a super popular piece of data just expired from your cache. What's next? Well, more often than not, it's a total system meltdown. All right, so this chaos we're talking about, it actually has a name. We're talking about a cache stampede, or as it's sometimes called, the thundering herd problem. And trust me, it lives up to the name. And here's the definition in a nutshell. It all hinges on that one single moment of expiration. The cache key for some popular data just disappears. And what happens next? The floodgates open. Every single one of those 1,000 requests thinks, oh, I'll go get it, and they all stampede towards their database to try and be the one to repopulate the cache. And here's how it all falls apart, like a house of cards. First, that one cache item expires. Then our 1,000 users show up all at once. Instead of just one request going to the database to get the data, 1,000 of them hit it simultaneously. Your database just can't handle it, it chokes, and pretty soon your entire server grinds to a halt. You can imagine this isn't just a small hiccup. This escalates, and it escalates fast. We're not just talking about a theoretical problem here. It has very real and very painful consequences for your app and, of course, for your users. So what does this actually feel like? Well, your database gets totally slammed, which means your API responses slow to a crawl. Your users are just staring at loading spinners, getting timeouts. And in the worst-case scenario, your server just gives up, runs out of resources, and the whole thing crashes. It is, quite literally, a developer's worst nightmare. You know, the crazy part is where this vulnerability often comes from. It's usually just a simple oversight. In the .NET world, we all love using IMemoryCache for a quick performance boost. But if you use it without putting some kind of guard in place to handle what happens on a cache miss, you are basically leaving the front door wide open for a stampede. Okay, enough doom and gloom. The good news is there are some really elegant fixes for this. Let's start with a couple of simple but super effective guardians you can put in place right now, especially if you're running on a single server. First up, we've got SemaphoreSlim. Seriously, the best way to think about this thing is like a bouncer at a really exclusive club. It stands right at the entrance to your database code, and it only lets one and only one request in at a time to do the hard work of fetching the data. So if you look at the code, that underlock.wait async call, that's our bouncer checking IDs. The very first request gets the lock and gets to go to the database. Every other request that shows up has to just wait patiently in line. Once that first request gets the data and puts it in the cache, it calls underlock.releases. The door opens and everyone else can just grab the fresh data from the cache. Simple as that. Okay, so our next tool in the toolbox is lazy-t, and this one is, well, it's pretty clever. It's less of a bouncer and more of a rock-solid promise. It absolutely guarantees that the function to load data from your database will be executed exactly one time, no ifs, ands, or buts. See how we wrap our database call inside a lazy object? The real magic here is in that .value property. The very first thread that tries to access .value is the one that actually triggers the database call. Any other threads that hit it at the same time, they just wait for that first one to finish, and then they all get the same result. It's a really clean way to make sure the database is only ever hit once. So let's put them side by side real quick. You've got SemaphoreSlim, that's your explicit gatekeeper controlling access, and then you've got lazy-t, that's the implicit promise guaranteeing a single computation. Both are awesome for fixing this problem on a single server. But what happens when we scale out? You know, when you have multiple servers all running your application. All of a sudden, our in-memory guardians can't talk to each other. The stampede problem comes right back, only this time it's on a much bigger scale. Right, the core problem now is that each server is its own little island. A lock happening in memory on server A is totally invisible to server B. To fix this, we need something they can all see. We need a shared, centralized lock. And this is where a tool like Redis becomes your best friend. By using a distributed lock, we create that single source of truth. Before any of our servers tries to regenerate the cache, it first has to ask Redis for permission. And Redis will only give that permission to one server at a time across your entire system. Problem solved. The distributed stampede is completely prevented. Okay, we've looked at all the individual pieces. Now let's put it all together. Let's build the production-ready, bulletproof blueprint for a truly resilient caching strategy. This right here, this is the gold standard. First, we use the cache-aside pattern with our distributed locks, just like we talked about. But then, we add a couple more layers of protection. We add a background process that refreshes really popular items before they expire. And we add something called jitter, which is just a small, random amount of time added to each item's expiration. That way, you don't have thousands of keys all expiring at the exact same millisecond. And all of this really brings us to a crucial final thought. Caching is not a set-it-and-forget-it kind of thing. It's an incredibly powerful tool, for sure, but it demands really thoughtful design and careful management. If you don't treat it right, it can easily become a huge liability. So I'll just leave you with this one question to think about for your own applications. Is your cache a fortress designed to handle the load, or is it just an open gate waiting for the stampede?